So let's try to find the center of mass for this pencil. So what exactly is center of mass? It is a position, that is, it is a point in any rigid body. Say for example in this pencil we have the center of mass here. So if we apply a force of F Newton at this point, the pencil will move forward in a linear acceleration. So when it moves in a linear acceleration like this forward, then it is known as this point is a center of mass. But if the force is applied at a different point, for example if it is applied here, then the pencil will move or rotate around this point like this. So this angular acceleration, if any rigid body causes angular acceleration, then that point is not the center of mass. So basically the definition can be that a point on a rigid body which when force applied on that point causes linear acceleration is the center of mass. But it is not necessary that the center of mass is always equidistant from both the endpoints of the figure or object. So say for example you have a rocket, the center of mass will not be in the center but somewhere here, because this part of the rocket might be heavier than the lower part. So the center of mass will be somewhere near the heavier part. So let's consider a guitar. Now the center of mass for a guitar will be somewhere here. So now let's see another illustration. Suppose we have two discs and a rod in between them. So the discs are of similar weight and same weight, and the rod is of steel or iron or anything. So the center of mass will be exactly in between, as both the discs are of the same weight. So if any force is applied over here, the whole object will move in a linear way like this. But if any force is applied to the ends, it will rotate. So if a force is applied here, the object will rotate. So let's say we have another disc which is of two discs which is of different weight. So this is a smaller one and this is a larger one. For this, and there's a rod in between them, for this the center of mass will not be in the center of the rod but somewhere here. So if force applied at this point, then the body will move in a linear way. But if a force is applied in between, that is at the center of the rod, then the body will have an angular acceleration. So let's look at another illustration. So let's say we have a slice of pizza and there's this naughty boy who threw this pizza in the air. So this slice will travel a path like this, and we know that this is a projectile trajectory. So the center of mass of the pizza is here. So as you can see, the pizza will also rotate, that is in 365 degrees. It will rotate 365 degrees while it follows this path. But what is interesting is the center of mass is always along the path, the trajectory. So as the pizza moves, all of its particles move in a complex manner except the center of mass, which is C, I've denoted with C, which follows a parabolic trajectory as if it were a particle of mass equal to that of the weight of the pizza. So this is like the basic understanding of what is center of mass. So let's see how we can find the distance or where the center of mass is in a particular object. So we have two objects, one is of 1 kg and second is of 2 kgs, which is suspended with a rod between them. So this is m1 and this is m2. So we have a formula over here to find the center of mass of any system. So x1 is the distance from the starting point to the center of mass of the first object. So let's say the center of mass of the 1 kg object is in the center of the circle, and here in the 2 kg object it is at the center of the circle. So let's say x1 is 2 meters and x2, which is the starting point, the distance from here to the center of mass of the second object, is 5 meters. So x center of mass, x is the distance, is equal to m1 is mass 1, mass of the first object, which is 1, into 2 is the distance, plus m2 is 2 and x2 is 5 upon 1 plus 2, which is equal to 4 meters. So from here 4 meters is the center of mass of the system.